can start. It's a great pleasure to introduce Onn Crouvi from the Geological Survey of Israel. We'll talk about Israeli Haboob. We will soon learn what it means. Onn did his studies in the Hebrew University, all of them, right? Correct? And then his postdoc in University of Arizona. Mm-hmm. And then since then he's in the Geological Survey since how many years? 6 years now. I strongly encourage you, as I did last time, to ask questions during the talk. I think most of us experience, we know that it makes the talk more interesting and more interactive. So by all means, I asked Onn, he's willing to be interrupted during the talk, so please feel free to interrupt and ask questions and make comments. Thank you, Onn, and let's start.
Toda Yoav. Hello everybody. I'm glad to be here again. I was here last time a few years ago. I think I talked about something else, and this is a new project that just came into print 1 year ago, and I'm happy to show it. Even though it's you're a marine department, that has also some importance to marine studies, as most of you know. But this specific study is not focused on marine geoscience, but you will questions. So the Israeli Haboob. Now explain what is a Haboob. It's not Haboob, it's a Haboob, it's a different thing. SIBRI is activating local anthropogenic dust sources in the Negeb loess, and it's with collaboration with Uri Dayan from the Geography Department at the Hebrew University, Rivka from the GSR, the Geological Survey, and Yehuda Enzel from the Institute of Earth Science at the Hebrew University. And the study is, the research is an ISF grant and by an international focus group of INQA, which is called Geodust. And as I just talked, what was part of the Eolian research, it's a journal on Aeolian studies, Aeolian geomorphology, and if one wants to read more about it, you can have a look over there. So dust cycle, and here is a cartoon, general schematic cartoon about the dust cycle on Earth, and of course the emission area. Here we emit the dust, usually from desert areas, and the dust being emitted and being over ocean, and it has a lot of effects on the environment and on the climate. For instance, impacts and impacts on the rainfall amount, and of course impacts on the areas where dust is being deposited, whether wet deposition or dry deposition. It can influence the terrestrial biochemistry, the ocean biochemistry, etc. And now there are a lot of papers and studies that acknowledge the importance of dust on a global scale, and just to take from the, like say, the 60s and the 70s, where most people thought the dust is, just something it doesn't have any implications, but over 20 or 30 years people really know that dust has a lot of effects on the climate and on environment. And even though it is being studied for a long time, there are many knowledge gaps about the dust cycle, and specifically about emitting areas, the dust sources, and this is part of the focus of this research. And it's important. Usually people study the dust cycle using global models or regional models, and one input that you need for the model are the source areas of the dust, and if you have areas, then the entire model can bring you wrong results. So this is very crucial for the model. So dust sources and a bit about the transport mechanism, and a bit more said about that can be divided spatial scales. There are many different scales for the division of the dust storms, but scale systems, and the most important on Earth. And I'm talking about systems that hundreds or few thousands kilometers in scale. These are the most important, but systems that are to a few hundreds of kilometers in spatial scales that are frequent in Africa, Arabia, and southwest of the US. And of the synoptic scale papers, recent papers, there is a big debate in the literature how these mesoscales are of the global dust cycles, specifically given the anthropogenic changes that now the human are making to the surfaces. For example, this maybe the are much more important. For example, this is the case that I will show you here. And as I said, specific and it's Haboob with the hey in Hebrew or in Arabic. It's not a cha. It's not Haboob. More like a friend, right? Like pop, like dude. It's not. It's a wind. Okay. So it's not. Although we tend in Hebrew to say Haboob, but so all this Haboob, they are right. It's not Haboob. And international common word. This go to the EGU or to the AGU, and you go to a dust session, you will see a European that talk about Haboob. So it's a common word in the dust. It means specifically for this driven dust associated with convective clouds. The moist convective mesoscale dust, usually where it goes up, then the air the cool outflows because of the thunderstorm, and we create a wall of dust. So in in Phoenix, this is probably a Haboob.
So it is caused by vertical waves?
It's going horizontally, very fast, and and of course we have available material here. Everything goes up.
Yeah, but it's wind that is
Yeah. Okay. And here I want to show you. Leo, can we have a quick move? If you Google, this is the Phoenix where I lived I lived in Tucson, but yeah. So here, this is in. And this is massive. And you see, it is, and it the 10 to 20 meter per second, and come back, and the specifically in Arizona, Tucson and Phoenix, and so the that synoptic scale storms, when you can track a few days earlier and you can see it in the pressure bars and then the maps and the satellites and everything. Here, the timing and the exact location of the Haboob. You can estimate the potential for the formation of the Haboob because of the convective conditions, but you cannot exactly when or exactly where you will have the Haboob. And along this highway, every year there are that are caused specifically because of the Haboobs, and several people die every year because of the Haboob, because brings the visibility down to 0, from a good visibility to 0 in few seconds. And if you drive 20 kilometers per hour, it can. Okay, back to Israel study area. As I said at the beginning, stories are believed to be a synoptic scale. This is the case also for Israel. Here we see a synoptic classification of dust papers even before the classification of the dust. The synoptic system that are that bring Russian, for example, the Cyprus law, Red Sea Tribe, and some other countries. So, specific to the synoptic systems that bring the data, and the it's a synoptic scale data. You can track the origin. If the dust that comes to Israel, that is being transported to Israel, is of distal origin. So if you ask today people in Israel where the dust, people will tell you from Arabia. But there is no mention for dust being emitting from Israel, from the Negeb. For example, and here it's the case that I will show you that I think that the sources within the Negeb are also important sources for dust. A system within Israel said about Haboobs, something in Israel, but usually when you talk about dust in Israel, you talk about the synoptic scale systems. And I mentioned here the total of dust emission from the Negev, but there is no direct evidence for dust emission from the Negev or from Israel. So the motivation for this research came from a specific story around 10 years ago, the 2nd of May 2007. I don't know if you recall this, it was 10 years ago, but it was in the newspaper, and it shut Sheva for a few hours. Nevatim airfield, it was affected, it was shut down for a few hours. Chatzerim also, these are the for one who don't know, the airfields. Was taken by a helicopter, and you can have the characteristics of a Haboob, the go direction to here about 1 kilometer, and I even interviewed the pilot. At the beginning he flew at the height of around 500 meters, and then he saw the wall of dust ahead of him, so we went up to estimate the height of the wall of dust to like 1 kilometer, and then he flew above it. So to store detail is the focus of the current study. So the aims of this specific diagram from the 2nd of May 2007 to examine the economic and synoptic condition that led to the identify the sources of dust for this specific story. We used field and we interviewed the people, the other army personnel, other people that experienced this story. We used the climate data that you can use. It's free, available online. We used wind temperature, relative humidity, and concentration data. I will talk so just a word about PM10 concentration of suspended small microns. And the Ministry of Environmental Protection, how we call it, Israel Haboob, has a network of PM10 measurements all over Israel, and of course human health. This is why we measure the PM10, because it's not so good to inhale the very small particles. And PTSP is the concentration of that grain size division. And observation in would go to like and observe the horizon every an hour or so, and they observe the horizon and say what to PM10. So we can do visibility estimation about concentration. So I used also visibility observation. So the northern Negeb, which is a short geomorphic background, as I just Team Airfield, which is near Beersheba. So we are talking, this is Beersheba, here a bit east to Beersheba. Nevatim here, Beersheba here. If someone really don't know about it, it's an Eoin deposit. It's a late Pleistocene in Israel. It's a late Pleistocene deposit. It and central Negev, and it of the western Negev, which are huge sand dunes of Sinai. And when it's in the nodes of the loess are crusted with physical or biogenic crust, and it's not so easy to emit dust, wind erosion from crusted surface, but the surface of the loess, it's really easy to erode the surface because these are wind-driven particles, okay? So, and now if you break the crust, they are really easily eroded. So it's important to know that, and we'll go to that later on. So you again are talking about the 2nd of May 2007. These are pressure in a 12, and this is in actually Israel is here. This is Beersheba, the Mediterranean Sea, Egypt and Libya. This is between the 1st and the 2nd of May, and we see here a in Libya near the border with Egypt, 5,000 kilometers far away from the law, far away from Israel. The time here and along this talk is in UTC, okay, the Greenwich time. This is the team over Beersheba. So we see that the core is still here. It is over the border between Egypt and Libya. This is again 1 kilometer away from the storm, and we can take a map that it cannot be responsible. This pressure law cannot be responsible for the storm that was observed during this time, because it's 1,000 kilometers away, and if you the pressure contour here, you expect easterly winds, and these are what was observed in reality, and we'll go back to it later. The 2nd and the 3rd is over Egypt, influence Israel. The Haboob was observed. We see that the pressure law is right now, we'll show it in a minute. The pressure law also brought dust from the Sahara, but again, the dust was transmitted by the law is accompanied of the pressure law and not 1,000 kilometers away. Okay, so that and the here observed at this time over the Negev. So, and I will show later how they are evolved together. And we see that comes entire area of Israel. And this is a images. We see here, this is few for the Haboob. And we see here, this is the Saharan dust storm. You see it's a region, kilometers, several thousands of kilometers. But Israel at that point, we see the entire Israel, okay? But it's a different storm. I will show you in a minute.
This is one day after?
Yeah, this is the modest image was taken, but the is here. So again, two different storms.
No, but this dust is not. You say it's not the storm.
No, this is this storm. The entire area, the entire Middle East. I will show. It will be easy here too. Yeah. So show some observation from Beersheba. This is the in blue, the relative humidity in red, and here the 2nd of May 12 UTC and 12 so 24 hours. Okay, I will show also the dust data. It will be clearer later on. So see that the in temperature. You see here the peak of the temperature from 24 and relative humidity from this is here from 6% to 20 down to 5%. So we see that there is a heating and the area, and we see an abrupt to 25, 10 degrees drop abrupt in few minutes, and it was a increase, abrupt increase in relative humidity from like 3 or 4% to almost 20. It is by a wet and moist air mass. Okay, and this is important later on. So just remember the wet, cool air mass that is accompanied by this haboob. And we go to all conditions of temperature and humidity, and this, the general story as we saw here. So it's a different story again. Again, this is the date and time. This is the wind speed, and this is the wind direction. Let's start with blue. So this is the regional Sahara. This is the pressure maps. We can estimate that the wind from the east, and this is what indeed what observe 2 or 3 meters per second weak winds. You can see these are the black circles, the wind direction from the east. And we see an increase in the wind speed reaching 10 minutes. Again, average of 10 minutes, reaching just higher than about meters per second. It's relatively high wind speed, and the high wind speed that observed during these 10 minutes, the was higher, reaching up to 20 meters per second, and this speed winds was accompanied wind direction to the northwest. Okay, so we see that the air mass came from the northwest, and abrupt increased, but still abrupt decreased in wind speed. The wind to east direction and wind speed to 5 meters per second. Uri, you want to ask something here?
Yes. The system, the Haboob, is it a system or just a form? Because you showed the cloud and the air going down and the front over here. So the entire thing is a system or just the front of the dust is the Haboob?
The term for the cloud storm, and there is a term for the dust storm. So the term on the wind, but it always relates to this climatic system of convective moist system.
Here and in the previous graph, if you have the two systems, one after the other, the Haboob and then the regional Saharan storm, in the middle you have an overlap, and you see it in both graphs. Here you see that it's over, and there's the certain cancellation between them. Maybe in the previous graph.
I don't. It's like only during when the coast arrived to Israel, synodic scale system, you see a great direction because the entire system is over Israel in the gust, but it's not.
Maybe the Haboob has a tail. When you see the front, talk about the front, but there is a tail. And until the tail doesn't go away, you still see the cancellation between the front of the Sahara and the...
Maybe it will be clearer later on when I will show the dust data. With the dust, you will see there are two separate events. They are not, I will talk about in a minute. But the sun is not related. Okay. Begin to know, and then this is the Saharan so scale storm. This is a mesoscale storm. And to strengthen I showed earlier, but this Hatzerim and Nevatim, a bit west to Beersheba, and Nevatim is east, and we see the same storm, and increase in wind speed in blue, also in Nevatim, but here you can see the different Beersheba is the because it is a bit to the west, you see it occurred around 11:30, while in it is about 30. So we see here the came from the northwest. And actually we think that what we see here is a development of sea breeze front. And this cartoon, these of speed during this day. Okay, so this is the wind speed in meter per second. Okay, so in 11:30, this is the wind speed during this day. So of the wind. Okay, through 1:30, and it northwest. And as I told you before, the air I showed before, actually, the air and moisture, water, then the air that measured before. So we see here a sea breeze. Sea breeze brings cold and moisture, and we see it according to the temperature, the relative humidity, and the wind direction that we actually see here the development of a sea breeze front, and we think that the gradient in temperature and gradient in relative humidity enhanced the sea breeze and it. And I will say in a minute what is a gravity current.
How is this associated to the graph you showed?
To the graph, sorry?
To relate this to the time series?
Yeah, to this. Yeah. In the later cartoon. So, 50 and the 20. So in 50, 1230. Okay, so the of the wind. Okay, so and it actually fits the breeze, a sea breeze. So again, is a breeze with a condition that prevents the wind that will prevail due to this loess situated over Egypt and Libya. It fits also the fact from the north west. Haboob was affecting. Okay, so it wasn't affecting much the area that was affected by the Haboob from Nevatim. And it's not a new thing that the sea breeze can advance into the depth. This is from MSG severe sensor. It doesn't relate to the. You can actually see here with this cartoon the it really fits what we saw before. You see here how the breeze. You see it now. I'm taking it back. Go and reaches even a lot. The sea breeze from the Mediterranean.
The date is correct, The date is correct, or is it the same system that you explained?
No. Sea breeze. It's like almost every day in this season you have the sea breeze. Just to show you the general scheme. And here it was put open. Actually, it struck idea between sea breeze. Again, sea breeze circulation increase the aerosol, the means the boker. So they found between the boker and sea breeze that bring high wind speed, even to the boker. So it's the same story actually. And the current, the definition is a fluid within an balance, and the different expanded material or temperature differences. It's related to temperature differences. We have cool air over dry air, and of course, where pure cloud can be described as snow. Of course, turbidity, maybe one of you works on turbidity currents. They are also known to be gravity currents, and even how can be described as gravity current, if one likes. And here described is the current theory. It was described early in the 90s. The sea breeze was described, and it was formed by 93, and we tried to calculate the theoretical wind. Here is the wind speed of the that we have during our specific case. In the density, okay, we have the density of the group and the okay, you can calculate, and these densities specific temperature, and you can it's between 300 to 500 meters, and calculate between 10 to 13 meters per second. In general, fits the observation of the 10 minutes average of roughly 15 meter per second.
In these pictures, I mean, gravity models, I guess you'd expect the terrain to go to dip toward the direction of the flow. And in your case, you go from zero at the sea, around the sea, to around 1 kilometer around the Ramon area. So you actually go up. How would it affect the velocity of the?
Well, I agree, but mostly here, but I think that Beersheba is 300 maybe, I don't know, the elevation. So it's not the Ramon. So I think here it's, I mean, probably it has some effect. So.
I think also there's a big difference in the concentration. What you have the mass that is moving, the turbidity currents, I don't remember the numbers, but it's much more dense than probably ammonia and salts.
Okay, now back to the dust data. I showed you only the wind data, and the data I showed you when that relates to what Uri asked. I will show you completely separate. And here again, you from data from several stations for direct PM, and we have Jerusalem here, Bet Shemesh and Rehovot, Central Israel. Original story, the data from the dust PM10, and you see here again abrupt increase and abrupt decrease in PM10, mostly or all increase in Bet Shemesh. Yeah, it might be that the Haboob affected, or maybe it was another small source here, but the Beersheba 50 microgram per square meter, and a complete even the Carmiel. In this case, we see lower concentration. It doesn't have to be lower concentration, but we see again that this is a unique event that affected only this area, and it has nothing to do with Jerusalem or the Galilee. So it's a completely different story. This is regional, this is a mesoscale local storm. And we convert data on the Nevatim from we see here. First, it occurred in Hatzerim, which is more to the west, and only then Nevatim. But the matter of time interval, measured in 3 hours interval, so it looks like it's after Nevatim, but actually, if we had 10 minutes interval, it should be in between Hatzerim and Nevatim.
The wind speed. You can calculate the wind speed.
Yeah. And one last thing, which might be the most important thing, so So the source would be here, and it came from the Sahara because the wind came here, so the source should be up the room. And I saw the potential source of the room. Now, soils. And here, everyone who drives through the northern Negev see the abundant crop fields, mostly wheat. And the field grazing. And of course, if you are grazing, the animals break if there is any crust after the agriculture producing the fields. And if you have crop, livestock make the material available for winter. And we know that we have the right condition. We had high-speed winds, 10 to 15 meters per second, really high. Just to mention, the threshold for dust emission is usually between 5 to 8 meters per second, and here we had 10 to 15 with gas over 20. And from Beersheba, she did some experiment, wind experiments in a control area that and we had dust emission than the control points. 6 in grazing compared to crusted of the northwestern Negev were the source for this storm. We don't have observation, but this is the most probable. This is if no one visited the northern Negev. This is, for example, an area in the northern Negev in Gilat, and just by green vegetation through index, a remote sensing index for the greenness of the area, of the vegetation concentration in the area. And we see here the NDVI controls up of in area near Nevatim. We see the NDVI it's drawn to the control near Nevatim. So we have a lot of vegetation during the time of the Haboob. Of the start of this. So we have a contemporary research of the late Pleistocene loess. During the Pleistocene, the loess was actually a sink, right? Because we accumulated that. So it's a sink of that during the last glacial. We don't have rates were low. Human interference and anthropogenic effect, the dust sink becomes dust source. So today actually is a new anthropogenic dust source because of human disturbance. And for at least one collect dust today in Jerusalem, for example, and relate the dust to the Sahara sources, and then say the Sahara was green or wet or dry, etc. Collect dust today, what you see is result of the desert loess. So part of the dust you collect today that to do a lot with the Saharan dust. Might be to do with erosion, wind erosion, because of the last 100 or 200 years of agriculture usage of the Negeb loess.
More digital and safe, mineralogically,
Yeah. Yeah.
it should be different.
Yeah. I agree. I agree. I mean, it should.
So you have to do this. So you have to get some definition there.
Yeah. So Yeah, I agree. I mean, there is a student that start to working on dust sample, and he's trying to separate the sources from in Jerusalem or in the Negeb. He will try to separate what recycling of the loess and what is a new, fresh Saharan dust. For one sentence, it's not that trivial because was originated from Saharan dust. So it's like a recycling of Saharan dust together with fresh Saharan dust. So it's not that trivial, but I think we can manage to separate the two. So to say, documented for the first Haboob in Israel, the sea breeze, and then the by agriculture practice and grazing, and we have is an important source of dust that is captured today in Israel. Thank you.
Thank you, Onn. You had several questions during the